Ayan, okay. Hello, I'm George Mendoza, and this is the 13.1, 13.1st uh, episode of the Philippine Ruby Group podcast. Um, what I'm going to do is record an addendum to the previous podcast. If you remember from the 13th episode, I discussed the Enigma machine based on that blog article on how on that simulation of the Enigma machine with 30 lines of Ruby. I when I ended that podcast, I was a bit I didn't know how to explain the I was left with some questions on how the machine worked. And over the weekend, I think I figured out what was the flaw in my explanation. So that this video is a quick attempt to explain where I got confused and maybe to set things clear. Okay, let me share my screen first. Okay, so if you recall, this was how the Enigma machine processed a certain character and how it encrypted it to its equivalent character. So when a when a when a user types R, that the user types I on the keyboard of the Enigma machine, the R character should light up. In order for that to happen, the the machine has to complete a circuit. So basically, your I is like a switch, and your R is a bulb. When you press the I switch on, it turns this particular circuit. It completes this particular circuit. And this circuit passes through different kinds of wirings, connections. There are these two plug boards that connect R and D and I with itself. We have these three rotors, sorry, that rotate and change the circuit as they rotate. And there's this reflector, which functions like a plug board in that it connects uh, two characters, J and R. So the problem on my mind last Thursday was, okay, it makes sense that if I press I, this particular circuit is closed, and as a result, the letter R light bulb uh, lights up. But how does that explain when I press R, there's a I light bulb that lights up? So it, I thought it was already, I assumed that it would be clear from this diagram, but in this case, it wasn't. So just to make things a bit clearer, what I'm going to do is highlight, oops, sorry, let's undo that. Never mind. But just remember that this particular R here is a light bulb, while this particular I here is a key. So the question is, what happens when I press the R key? Why does it light up the letter I? Because that's the opposite. That's the decryption process. I figured that the possible explanation for that is basically you'll have, remember that this I here is a key. On the other side, there's also a R key. I'm going to name it R key just to make it clear. And I'm just going to name this also I key. I key, yeah, I key. And this one I'm going to name R bulb. On the other side, we're going to have an I bulb also, right? So what happens is if you press the R key, what you'd have is another circuit connecting to your plug board, the same plug board. So right, let's say just put it here. So if you remember this plug board connects two characters R and D. So if you press the R key, it passes to this plug board through the R connection and gets routed to the D. And because it follows the same path, D is connected to Q and to K and so on, you end up to the other plug board on the other side. And from this point, your plug board is now connected to your eye bulb. And this eye bulb, let me see, oops, sorry, that didn't work. There, that's better. So what happens is that if you press the R key, you go in the reverse direction. You start with the R connection of the plug board, then you move in the reverse direction of the circuit, ending at the other plug board, which is connected to the eye bulb. And this eye bulb is connected back to the R key. That way, if you press the I key, then only the R bulb should light up. And if you press the R key, then only this particular circuit is the one that is closed. So uh, so you might be thinking, does that mean that in this case, I know that the R key is connected to the I bulb and the I key is connected to the R bulb. But what about the other? Does that mean, what about the other keys and bulbs? Does this mean that, for example, the R key is connected to all the bulbs, all the bulbs of the alphabet on the machine, and vice versa? Is our R bulb connected to all the keys of the machine? And I think the answer to that is yes. I think that's the only way. That's the only way. I can only imagine that the machine has a lot of wires connecting all the keys with all the bulbs. That way, you only need to press the key in order to light up a certain circuit. And that way, if you do change, once the rotors change or once you change the plug boards or the reflector, your connections will still be intact. One way you can imagine this is, I'm not sure if this is, I doubt if this is how it is built up, but you can try imagining it like you have the battery on this side. Mhm. So because you need a battery to connect to make the circuit run. And that battery handles all of the connections from all of the keys and all of the bulbs. It's like this single point where all of them are connected. That's one way you can imagine it. It's not mentioned in the article or in the videos, but hopefully that might help. So that's it. This explains how the machine is able to decrypt the same code using the same cipher, and it also explains how when the rotors rotate, you have a different route for the key, and as a result of that different route, it changes the bulb that lights up. Thank you very much. Hope you had as much fun as I did studying this interesting machine. Uh, I will. I don't think I'll record a podcast next week. Maybe because of the Ruby conference. Maybe we'll do it the week after. So that's it. Thank you very much. Have a great weekend.